Let's look at what we were doing yesterday. And we are going to finish this and then look at tweaking parameters. So we have that the virus has started with 3 and it multiplied by 5 every day. We were able to make our table and our function. So 3, that first number is what you start with. And then the number that is with the exponent of x, that's your rate, how much it's increasing by. So you were supposed to do, let me get another color because it's hard to see. 1, 2, 3. I think that's all we can really go. So the x-axis, what does that represent?
The amount that multiplied by 5.
The days.
Days, yeah. Number of days. And what does the y-axis represent?
The number of viruses.
Yeah. So let's graph it. So 0, 3 would be really, really low down here. 1, 15. 2, 75. And 3, 375. So let's talk about the domain and range for this situation. Not for the function yet. We'll talk about domain. So for this function, or for this situation with the viruses, x represents number of days. So what is our domain? What values represent the number of days?
1, 2, 3, 4, 5, 6.
0.
0, right. Yeah, 0, 1, 2, 3, and ... so on to infinity. And then our range, what are the y values?
15 or 0.
Well, it'd be 3,
Oh,
right?
yeah.
15, 75, 375, and so on. Okay, and then for our function, f of x equals 3 times 5 to the x, our domain. So that's when they're connected. Let's go ahead and graph this in the calculator so we can look at it. Clear out your memory so we can just start fresh and so we can look at it. So it's y equals 3 times 5 raised to the x. So we graph it. Okay, what do you notice about this compared to our linear?
It doesn't start here. Oh, wait, no. It's like this. And then it goes up.
Yeah, it has this like straight line right here, and then it goes up. So what does a straight line mean?
It's a 0.
It's close to 0, like on the y's. Does it ever go below the 0? No. And if we look at our table, let's look at our table. And let's look and see if we go to the negative x's, like where the line is. What do you notice about that y1? These are,
Exponent?
well, what is,
E?
I think
yeah.
like air, I don't know.
No, it's not error.
That's the scientific notation.
Scientific notation. So whenever it's negative 11, it's like 6.1 times 10 to the negative 8.
What?
Remember with scientific notation? Let me write it down real quick. Just on a note card. Well, I'll actually put it right here. So negative 11 is 6.1 e to the negative 8. And what this means is 6.1 times 10 to the negative 8. This is going back to scientific notation, like Carter said. Do y'all remember how to convert this to a number, not in scientific notation form?
Move the decimal in 10 places.
Do what?
Move the decimal over 10 places.
No,
Oh, no. It's
8 places.
8 places.
Yeah. Which way, if it's negative, is our number going to get larger or smaller?
Small.
Smaller. So let's move it over. 1, 2, 3, 4, 5, 6, 7, 8. There's our decimal. What goes in all these little spaces? There. Ignore that X right there. Just kind of right into it. So this number is really, really, really close to 0. But if I keep on looking at these numbers, so see how the decimal or the e to the number is? It keeps on getting bigger, or actually smaller because it's a negative number. So what does that mean about that line here? Is it ever going to cross 0? Is it ever going to go below? No, it's not. And so this is what's called an asymptote. It gets closer and closer to a certain number, but the function, the graph, never crosses it. It's like gets infinitely closer without ever crossing. So whenever we had our vocab, asymptote, a line that is approached or may not be crossed. So in this case, the line is this right here. That's our asymptote, which this line would be, it's a 0 slope, right? And it's on 0, so it's y equals 0. That is our asymptote, which sounds like a bad word. It's a line that is approached but never crossed. So when you have an asymptote, now listen, when you have an asymptote, that is going to affect your domain and range. It just depends on which value we're talking about. So which one will it affect? If it's y equals 0, will it affect domain or range? The range, why?
Because it goes up instead of like the domain just stays the same. It's safe.
Domain is X.
Yeah.
Right, that's it. Domain is X, so it's not going to be affected by the asymptote, but the range will be. So let's just talk about domain now. So domain's not affected by this asymptote because it's talking about X is going left and right. So if we look at our graph, it's going to go left and right to infinity. So our domain is from negative infinity to positive infinity. But our range is not going to cross y equals 0. So can we say that our range is like the other ones where you say negative infinity, positive infinity? Where is it going to start? 0. Is 0 going to be included? That means it touches it. Does it touch it? No. So it's just going to be less than. If it had the line underneath, that means it crosses it's or equal to, so it's not. Y, and then it goes on to infinity. So it's going to keep on going up to infinity. All right, let's look at that tweaking parameters now. We're going to look at several different exponential functions. See how these are all exponential functions? And actually what's graphed on here is the exact same. Do y'all see? It's the exact same functions. And it's the exact same that we've been talking about. Start with 3 viruses, multiply by 5 every day, which our recursive rule is start with 3, and then next equals whatever we have now times 5. So our new recursive rule on this one is going to be, we're going to start at 5. But we're going to keep the same. Next equals now times 5. Do what? So this is the one that's already graphed. This is our new one that we're going to compare. We're comparing this one, our original one where you have the 3 viruses and you multiply by 5, to a new one that we're looking at. We're starting with 5 and we are multiplying by 5. So what is changing? This is our original. This is our new one. What changed about it? Starting point. So I'm going to put that over here. Change the start. I'm going to use a pencil just in case I mess up whenever I craft these. So can we find our new rule? Yeah. What is going to be our new rule?
5x plus
5 times
3.
5 to the x.
Oh, I thought you changed them.
Nope. The only thing I'm changing is the start. So see how the start is that? The rate is the exact same.
Wait, but why did you need to change the starting point?
This is like a new problem string.
So did you like make that up?
Yes.
Okay.
Yeah. This is just made up. We're talking about a new one. We're going to change the starting amount and we're going to compare. That's all. So let's make an X and Y table so we can graph some points here. Okay, so we are starting with 5, so we're going to put 0, 5. And then after 1 day, what is our new Y value going to be? Start with 5, multiply by 5 every day. 25. Good. Okay. Then 2 days.
125.
125, because you multiply 25 times 5. 125. The next one? 625. Okay, cool. So let's graph it. So 0, 5 would just be right above that 0, 3. 125, so 10, 20, so 5. 2, 125. Oh, that's going to be hard to do, isn't it? Basically up here, right? It's hard to do, so I'm not even going to do it. I'm just going to do something like that. So the rate stayed the same, just your y-intercept was different. So remember in linear, when your rate is the same but your y-intercept is different, how do your lines look? Parallel, yeah. We can't have parallel exponential functions, but they have the same rate. They're increasing at the same rate, but they have a different starting amount. This is called a stretch. It was started here and it's going to be stretched up because our original, what was our original table? our original table was 0, 3. So it's 3, 15, 75, 3, 75. See how much faster this one grows, even though we didn't change the rate, but it's still affected because of the starting amount. Let's do the next one. Same recursive rule for this original one. This time we are going to start with 1. And we are going to keep the same rate. So next equals now times 5. So what did I change?
The star.
The start. So again, change the start. So I'm going to put that over here. Change the start. So what is our new function rule going to be? Where does the start belong in our function?
1 times 5 to the
Yep. It's that first number. 1 times 5 to the x power. It's that first number. What do you think is going to happen to this one? If this one was stretched because you started at a higher, what's this one going to be?
Slow.
A little slower? Yeah. Do y'all know what the opposite of stretch is?
Short.
When two things push down on each other.
compressed.
Yeah, compress. So it's a compression. So let's look at x, y. Let's do our table. So this is start out with 1, multiply by 5 every time. So 1 times 5, 5. And then multiply by 5 again. 5 times 5. 5 times 25. And then 4.
6 1.
What would it be? Sorry, I didn't hear.
620.
Yeah. So it's really similar to this, but you have to start out with the 0, 1. See how they're the, well, yeah. Okay, so 0, 1 will be closer to down here, closer to our 0 amount. Then we have 1, 5. 2, 25. 3, 125. So it's like that. Something like that. So our original, if we change the starting amount, that's going to compress it. So let's put compress. This one was a stretch. This one was compressed. Okay, let's look at this next one. This time we are going to keep the start the same. And our rate is going to change. So this is going to be now times 2. So how is that going to change our function rule? What did we change? Starts the same.
Oh,
And now.
And now next equals now times. So we changed the rate. So write that over here. Changed the rate. So how is that going to look in our function rule?
3 times 2.
Yeah. 3 times 2 raised to the x power. So it's where the exponent is. It's the base of that exponent. X, Y. So let's do our table. So we'll start out with 3. And then we're going to multiply by 2. So what would be the next number? 6 times 2 again,
12,
times 2 again,
24,
times 2 again.
48.
Yeah. Okay, so that's all I'll do. So we can put this in. So let's see. 0, 3, same spot. 1, 6. 2, 12. 3, 24. If I do like, it's like that. Something like that. So it has the same y-intercept, but what happens to our graph? How would we describe that?
It's not as steep slope.
It's not as steep. So it's going slower, what did we say that was over here?
Compressed.
Yeah, it was compressed. So it can get compressed in 2 different ways. One way would be a lower start or a lower rate. So those are the 2 things. All right, number 4 is going to be, we're going to stay with the same start again. But this time our rate is going to be next equals now times 10. What do you think is going to happen on that? It's going to be compressed or stretched?
Straight.
Stretched. Okay, what's our new function rule then? Yeah. So again, change the rate. Okay, so 0. It's going to start with 3. And then 1. So times 10, what would that be?
30.
30. Okay. 2 times 10 again.
300.
All right. The next one.
8,000.
Okay. That's probably good. So it's adding a 0 whenever you multiply by 10. So we have 1, 3. So same. 0, 1, sorry. And 1, 3. So 20, 30. Woo, it's going to go up really fast. So what are we going to call this? What kind of change is this? Yeah, it's a stretch. So it increases a whole lot faster. I think we're going to end here so that when we come back from spring break, we can review this, do our last one, and then continue on from there. No assignment tonight.